We're going to move on to our next talk, but just a quick reminder, there were a number of questions in the queue from this talk that we did not get to, but I wanted to let you know we do have a CERT Secure Coding forum on LinkedIn. If you just go to LinkedIn, search by group for CERT Secure Coding forum, you can add any questions there. We have a number of staff members that can answer questions there as well. So our next talk will be Continuous Integration, Secure DevOps by Hassan Yassar. And Hassan is the technical manager of the Secure Lifecycle Solutions group within CERT at the SEI. He leads an engineering group on software development processes and methodologies, specifically on DevOps and development, and researches advanced image analysis, cloud technologies, and big data problems while providing expertise and guidance to SEI clients. So, Hassan, welcome. All yours.
Thank you. Thanks, Shane. Thanks, Mark. I'm glad to be here. So, I'm going to talk about today and starting from DevOps and then understanding about the continuous integration, and also talking about how can we get security into the development pipeline. So basic things about the DevOps and what DevOps means. So initial DevOps movements begin based on the reaction. What the reaction means, like typical things in development lifecycle. As a developer, we develop something, and then after that, we handing over to operational folk, which is a production team. If something happens because of the siloed environment, an operational team are responsible to fix any problem, any type of vulnerability things, or any type of system breakage, anything else has to be done from operational team. So it's creating a more problem on the development side because there is not connection between operational folks and development folks are not connected because of creating more problems. So initially that term started in the conference in 2008 in Agile conferences, and Andrew Clay Schaffer and then Patrick DuBois. So they were talking about the agile infrastructure, basically connecting operation and dev team together. Then after the 2009 and DevOps terms start to have a DevOps tier organization as throughout the conferences that became so familiar around the world. So let's talk about a little bit more deep diving into what's the problem, why the DevOps is really solving that type of problem, what is the problem initiated. So mainly for almost every developers are doing the agile development process, which is a very common techniques right now nowadays. So basically starting from planning and talk about the requirements, acquisition, and then design and implementation, evaluation. It's kind of like a constant process. So when we look at a little bit closer in that process, looks like still we are doing some sort of a siloed things within that agile process. Like typically, I like that slide, it's a kind of just humble slides. So talking about the water, basically business looking for what is the research, what's my business direction, what I'm supposed to do, and what is my budget about it, and how much I'm going to get requirements, basically total depend on each other and continuously based on the water approach. Then when it comes to this development team, it's basically Scrum, which is the actual agile development is happening over this continuous development, continuous iterations, and continuous working together within the development team. Then it is handing over to the operational folks, which is QA teams gathered, and when the QA teams got that stuff, looking for the integrate and test and release. So basically, it's kind of overall water Scrum full process. So when we look at a little bit closer, actually we are creating a silo. Even though we are saying in Agile, still there's a silo between the dev team, between operational team, between the QA team, between analysis team. We're going to talk about the security team later on to fix the problem. So typically there's a silo within an organization. We start for Agile. However, we turn out to be using a waterfall approach within that Agile framework still. Like specifically, if you look at closer, we have the requirements, we have the design and implementation, which is basically developers are dealing about it. Then handing over to the QA engineering, which is a verification process, right? So QA engineer is working by itself as a standalone. Then when it is done, when it goes to the maintenance section, which is the operational team guided. So we start from Agile, and our business is Agile, but we ending up having a siloed environment within the Agile process. So that's the typical things is forcing us having a waterfall approach instead of connecting, instead of sharing, instead of working together, creating a siloed environment because of what the business, what our process does. So let's talk about maybe DevOps things. If anybody has to hear about more DevOps, we can deep dive on it.
Okay, so the polling question you'll see now on your screen is, would you like more information about DevOps, or is it a concept that you're basically familiar with? So I'll give you about 10 or 15 seconds to vote, and if you want to wait a second, Hassan, we'll just take them real time here, and I'll give you a chance to. We got about 59% saying yes so far. Let me just hit it one more time to update. 63%, yes.
So it's a,
Like,
it's a great topic, actually. I'd like to talk about more if time permits. So DevOps is the very common things is industry right now is commonly used. And if you look at how the Google is doing it, how the big enterprise companies are doing right now, Google or the Etsy or the Facebook and Flickr, and then that company's Amazon, it's basically a DevOps mentality. They are using it faster and to catch the release and be connected operation environment. So it's a very common term, very common things getting very popular industry. So when we get into as the car manufacturing industries for other industries, it's kind of lacking behind that integration or behind DevOps process. So it's very common, as I said, and getting a development team or operation together. So if you look at the verb, DevOps means bring a developer and operational team together. So typically, as the name is, getting operational and development engineers, putting in the operational team and development engineers throughout the software development lifecycle. So what the software development lifecycle is, starting from beginning to the end, including the production support as well. It is not only limited to the development process. It is including the business aspect and also including the operational aspect. So if you look at that, it's basically Agile is looking for more the constant change, more the development cycle, and DevOps is getting from business and also getting operational, getting into together and working together and to the same business goals. So DevOps is constant testing and delivery, and also embedded operation things for the DevOps. Like what operation means getting operational team as part of the DevOps, part of the development process, part of the engineering team, part of the overall stakeholders together. So think about any example, like think about today's car problem, right? If you're gonna talk about the car cases right now in terms of security, as whoever has the stakeholder for overall project team in terms of software development, they have to be part of the process. It is not at the end, has to be beginning of the process, including the business requirements. Like we are looking for the functionalities, what the car typically function does in terms of supporting Bluetooth, supporting Wi-Fi, and supporting the car audio, supporting other nice technologies like lane departure warning, everything else. It's a business needs. So business says, yes, we have to do because our competitor has to do that type of features. Now we have to do similar things in our environment. Right, so business needs is over there, which is coming to my requirements gathering thing. There's, okay, we have to do it. Let's make that business things getting done quicker because there's a pressure to get into the market. So that's another team is getting into their architectural team and the requirements team and design teams getting together and goes to development teams. Development teams are working to make that happen. And then when it comes to the testing phase, which is going to another siloed team, which is operational and doing some sort of testing. So DevOps is bringing together and let them communicate, let them collaborate, let them talk together.
So how would you see that in the cyber-physical world? The examples you gave, Google, Facebook, Etsy, are known for doing thousands of A/B tests simultaneously, and their operational environment is another computer. If your operational environment is the Jeep, how is it that you have continuous integration and updates and alternatives?
So actually, it's getting much easier to answer that question when we compared 15 to 20 years ago, because all the cars is getting more technological things. So if you look at the Grand Cherokee Jeep case and what problem was it about, it's all the softwares is running on the sensors. So at the end, it's all about the modules. It's all about the softwares. It is, even though it's a physical things, but however, they are talking based on the sensors. So sensor is like either getting the brake or looking for the Wi-Fi, looking for the other type of measurement within the car, but running in the software APIs. So like Harman system, there's a bunch of APIs and it's a software application. So think about how Amazon is doing it. Amazon has a bunch of web applications running web API. So in the car case, we have a lot of web API running within the container environment. So we have a lot of small modules or a physical system seems, but running a web API in it, running a web services in it. So bring that architecture into the platform so you can integrate together and then working based on each individuals. So basic using a simulation techniques, using some sort of like virtual testing, which is very, very common things you can do. How we are testing an application as use case testing, we can do similar things for API, we can do similar things for the sensor. Let's say you're gonna do some sort of like a testing modules for self-parking systems, right? So if you look at self-parking system, there are many other quality attributes you can test it out. So give some scenarios, which is very common things. There's a lot of simulation scenarios for car building or testing the car. So build that scenarios, looking for what type of sense is going to fit into the brick systems, like typically motions, most like the camera system. So all the system can be virtualized and using the sensors and virtualize basically what type of things we can play around it and integrate together, which makes much easier with the DevOps mindset, with the integrated platform. Versus it was difficult, now it's very easy because everything is software.
So the current state of the art is to use some sort of simulation in this environment.
Absolutely. And simulation, and also even though you can simulate some of the supply chain stuff as well, if you don't know somebody else work and try to simulate it, what is the endpoint and input and output, and try to connect together. So I'm going to talk about I think we covered some of the slide, that DevOps aims to increase of innovations, response to the business needs, and collaboration and software quality. So that's the typical things for DevOps is really focusing and to catch the business needs. So in the car industry, we would like to catch up the business needs. Yes, we have to do DevOps because we would like to catch up the business needs. That's the way it is. And how can we increase the quality? Which is we have to use, the integrated pipeline, increase the quality. That's the main things for DevOps. The increase is in terms of the advantages and then moving forward. So DevOps typically has 4 primary focus areas. And talking about the collaborations and the main things, and infrastructure as a code, automation, and the monitoring. These are top 4 primary focus areas. When we try to get the DevOps into the integrated platform pipeline, then we have to talk about the collaboration, infrastructure, automation, which we're going to cover up the continuous integration, what the continuous integration means in terms of automation, and also the monitoring thing. So I'm going to cover up a little bit and then talk about more in the continuous integration as part of automation. So what is about the continuous integration? So when we talk about the continuous integration software environment and talk about getting all these little pieces together, so it's not only the one team does everything, there are multiple teams. In a very small projects, we have many other teams are working in a different side of the application. So in the car industry or another industry, doesn't matter which industry it is, many other developers are working together. So when we bring the code, basically we have to merge to make things happen. So when we merge our code, getting a lot of problems that we will see because almost all the time, what we are running as a developer is going to run very well in my machine, may not run when we integrate together with somebody else, right? So that's creating a lot of conflict when we try to integrate together. It's all about the integration, see all the problems. So it is often creating a manual process in the integration piece. Once we get integrate means like get my code, integrate together, and then see the problems. So if you have a manual integration, as instead of using an automation piece, we see a lot of problems. What the problems are basically overriding somebody else's code. Maybe we don't understand each other's. Maybe we have some sort of like misunderstanding from requirement scheduling. Maybe some other defects we don't see each other. And also when we try to the manual process, which is all time consuming. It is time consuming in terms of integration and somebody has to do it. And somebody has to really integrate the code and test it out, which is disconnected from the components. It's a slow process. And also lack of transparency. What that means basically, if I see some problems in my integration, I'm not going to see until then I integrate somebody else, which is I don't know until I integrate it. Maybe I'm running some sort of modules, it's going to communicate with some other team's modules. We're going to see once we integrate it. Instead of waiting maybe at the 3 months or 2 months, then we cannot see right away the results. So that's important stuff to have some sort of integration in terms of as a continuous integration. Let's talk about, I think the polling question.
Yeah, the next polling question where you have launched on your screen now is, do you currently implement continuous integration in your development lifecycle? So we'll give them about 15 seconds to someone if you want to keep going, and we'll circle back to that.
And I can give some kind of like life-limiting examples with what happened to me. And then almost 15 years ago, when I write some software for this, for this flight simulator business. So we were using the code and carrying out this floppy disk, tried to integrate it. We were going back and forth with the server room, and then we were queuing up. And whoever the persons integrate into the Linux machine, so basically lining up and try to integrate our code as a manual process. So like we are going running back and forth. So what we find out as automation piece, like somebody was writing and changing the code, and somebody was waiting in the front of server room, handing over the CD or the disk. There was no actual CD at the moment. There was floppy disks, and having some sort of automation, not in a manual process automation, which is a human involved in that process, instead of having as a fully automated process.
And to wrap up our question, which was, do you currently implement continuous integration in your development lifecycle? 52% yes, 48% no. So kick it back to you.
I'm kind of like surprised when I see the result. It looks like half people are using continuous integration, half it is not. That means we are missing a lot of the good stuff that continuous integration is offering for us. Let's deep dive into the integration, what automation means. So basically, having an automation, it is going to fix the inefficiencies, and it's going to create standardized artifact submissions and guarantee the consistent results, and fail test and reduce the pain of integration. So I'm just going to go to one more step, and then that's a typical software development process, right? Development process, including the component, including all other development teams. It's very difficult maybe read the slides on the screens. If you guys have a chance, we will look at for the PDF that you can download it. So it is all about the users, documentation, integration piece, and talking about the code review and monitorings and the communication piece. So the left-hand side is all about the human, and our goal is really integrate. Let's have a less human actions into the software development process. Let's handle a lot of stuff, which is the integration piece can handle that automation in terms of the integration into the source code repositories, integration into the issue tracking systems, integration with other software development process. That actions can be done more autonomous, more and then automated way and integrate all together. So goal is really get all the pieces together and working and integrate automation. Then it's going to be much better in terms of see the progress, in terms of see the collaboration between the team members, in terms of getting results, what the continuous integrations fail, and get the fail results and share the team members together.
So especially for large teams, how do you manage collisions?
So in the large
with,
team,
with multiple people updating the same pieces of software at the same time. So I don't know if that's a common term or
so
not. Yeah.
actually, having a continuous integration server or integrated platform, it is going to solve that type of problem because there's a software things that either we can have a branching in the software modules, and then once we integrate together, that may be a collision. Of course, it's going to be when the collision happens, we will see the results right away. So we will see if our build service failed, and then our chat bots or the chat operation or some message that goes to the development team, they will see right away, here's what I'm failing, and I have to go back and change it. If somebody break the code, if somebody push something into the repositories, either overriding or creating some other problem, we'll see immediately instead of seeing at the end, we can see as part of the automation process. As soon as build service run, and they will get results, and then team is going to see what is going on. So key point is really actually the sharing the communication between the other team members. So sharing communication between team members, the continuous integration server can send the results direct to the development team. As automated fashion, they will see what is really breaking the code, giving the explanation. And actually, next slide is going to talk about more what integrated platform means. So in the integrated platform, it is not only the for source code repositories, has to be integrated with other components of the development process. It is not only the repositories I'm talking about. It should be part of the documentation, part of the monitoring server, and part of the other the code review systems. And we talk about the static analysis, code analysis can be part of that process as well, which we're going to cover up in a couple of minutes. So once we integrated overload development pipeline, that means if I'm using this same chat server, if I'm using the issue tracking system as other developers, then based on what I'm committing into my code repositories and my issue tracking system is linked to my code repositories, linked to my CI server, and my CI server will then fail and give the results back to the users, and then I'll get immediately the answer.
Do you want to explain a little bit about what are all the elements that need to be automated in order for a DevOps operation to be successful?
So actually, DevOps is requiring to have automation almost every component of the development pipeline, starting from ingestion, the beginning, what the user requirement. As soon as when the user requirements is being created, and then has to be part of our pipeline. So how can we do that? Basically getting a documentation that we created from the either requirement, which we talk about, Chris will talk about the SER and other things. So once we get the requirements is done, and then adding a security into pieces and other function requirements, put into the issue tracking system. So let the developer using the same platform. So using Jira or some other issue tracking system and try to document every functionalities into the either Epic or based on what the organization is going to use the development process, maybe using Agile, maybe using SD. It doesn't really matter as long as if they have have a common portals, and all the requirements can be documented over there, which is the first steps. Then once we have, and which is the basically issue tracking systems and the wiki pages, then everything has to be treated as the code as well. So if you have a documentation is using a Microsoft Word, you may not be able to keep the versioning and try to convert in the text format. Why is that important as text format? And I would like to be creating every artifact as the code. So every artifact is treated as a code, so we have a versioning about it. That means developer has the 100% accessibility in and how they are doing the code development. They can see the documentation as well as part of the process. Because developers are looking for what these things I have to do, what is the requirements that I have to do, what is my constraints that I have to do. So you give them a same comfort zone that developers using it, which is the code-based environment, and we integrate into the as the part of code. So, and also code base has to be integrated into the issue tracking system. Why is it important? And specifically in this thing is very important in terms of software security vulnerabilities. If something happens to my code, I should be able to trace back into my requirements. And I should have a history in the system. What is the history that I wrote and who touched that code, and what is the mindset, maybe some notes. And typically developers, we are writing something at the moment, we have a lot of ideas. When the 6 months past the code code commit, that I don't remember anything that I wrote it. So it's gonna give a traceability back to my original requirements, including my documentation as well, including my commit messages too. So we have the repository that we integrated. And other things, once we integrate into the CI environment, which is the continuous integration, we can validate our test results. And did we pass the test? Did we fail it? And did we fail another security testing over there? Did we fail another the compliance testing? So with another history that we can really go and take a look at it. So that means all of them has to be integrated into the CI documentation server, including the issue tracking system. So DevOps says you have to integrate all possible. So this is typical CI models, and which is getting source code repository, which I think cover up some of the stuff already, and then having a more integrated platform and more connected into the development pipeline. So I'm just going to start from the security aspect of it. So let's talk about how can we get security into the DevOps pipeline. We cover up the overall DevOps work, and then let's get the security. So again, going back to DevOps mindset, and then security is another team. And then we talk about the software practices, we talk about the requirements gathering, we talk about all the team members, including developers, and then developing the QA, IT operation things. But however, the security team is kind of isolated, it's not part of the development team's main idea is bringing together as the whole team and working together throughout the same goals. So in DevOps is getting all together and getting a security in piece, and security is part of the development process. Instead of staying outside the process, has to be internal, has to be integrated the process. So I'm just going to cover up quickly. I think if we have enough time, we can go to the polling question. If not, we can switch to the security operational
I'll
stuff.
just launch it real quick and let you keep going. Just asking, we just would like to know the audience, at what point do you consider security in the life cycle?
So. And then as talking about DevOps things, it's a good opportunities, and then it's going to help bigger organization or small organization get a security team as part of the overall process instead of staying outside. So security team can be part of the process multiple ways. Can be part of overall process also using automation techniques, using best practice, using a security requirements gathering, or the team can be part of as a manually or as an individual expert in the process. Instead of security folks are checking an operation at the end, and security folks has to be part of the process at the beginning, like starting from requirements gathering. If somebody is in that case, if somebody is looking for the specific, what type of the embedded software or the supply chain or the operating system they have to use, and security folks, they will verify that either supply chain they're going to verify, or they're going to verify other, the OS they has to be using some vulnerability, they can verify that version instead of let developers doing something, and at then they're going to go back and change it, so that operational team has be part of the overall process, including security teams. So this is the typical DevOps cycle here, and talking about, again, the same thing is connected to QA and then code and testing, and then also including business, which is injections, and then project configuration overall process. And the next slide is basically talking about the transition. I think this is a typical DevOps cycle process, basically typical software development process, including operational perspective. So when we look at here, there are many, many steps that we can address security. So like starting from the beginning to end, and question to everybody, so where we can address the security. I'm just going to start quickly and then try to cover up as much as I can throughout the rest of my time. So starting security is actually as early stage of the develop process. When we have to start from the beginning. When we have an inception, which is the requirements gathering. So we have to have a secure requirements gathering at the beginning. We have to be really looking for the security is not as part of our the quality things has to be part of our non-function requirements. So typically in the business, it's about the security requirements. It's about the requirements, but it's not listing as what is the security requirements about it. So we have to use the security requirements at the first process, at the beginning. Then when we go the next topic, which is getting our pipeline, which is pipeline is about the project and then setting up our infrastructure. So that means like setting up the repository that we're going to use, setting up our operational system. It's going to be secure, looking for other artifacts in the system that we're going to have to make sure we have a secure pipeline and hardening an environment that I would like to use. And if one of the component in the bigger picture is vulnerable, and who's going to tell us? Security folks is going to tell us, make sure you have a secured infrastructure in terms of small sensors, maybe using as embedded OS in it, make sure it's secure enough, which is the part of the project development process. Then we can talk about the code review process, and the code review process, we can add a lot of static analysis, checking, and fuzz testing, dynamic testing to the code review process, which Bob Shelley talked about integrating security practices in this place. So this is kind of like a very important step. Once we integrate into the security, into my best practices, and it's a kind of constantly operational things. They have to, they means all the developers have to learn and have to understand together. So think about if you did any code analysis, if you did any static code analysis, if my code analysis tool is going to tell me what I'm supposed to do as in terms of best practices, and what are the typical things I'm failing, if I put everything into my continuous development cycle, and all my development team members, they're going to learn what they have to do in terms of how we can fix the basic security requirements like authentication, or how we can check the origin as the authentication of the code, origination, who's calling me, and then look for other things. So, and then not everybody's going to learn everything in terms of security practice. However, the system can teach us, can expert teach us, can tool teach us over the development process, and all the developers understand the secure coding, and then learn together, building a library together. And next step is the continuous integration. The continuous integration, which we can do a lot of testing over there. We can do fast testing. So the common thread in the industries, maybe business need is so demanding, they may not able to get everything else as tested out. Like pen testing, it will take time to get the pen testing out because it will take maybe a week or 2 weeks. However, while we are doing the feature release, let the pen testing going to continue as your development process. So it cannot be as a road blocker, it can be part of the process. Once we have the result from the pen testing, once we have a result from our continuous integration, so we can feed back into my development cycle and try to address all these security requirements, all the things that I failed through my testing. So that has to be continued throughout the development process.
Has there been any experience in trying to understand the economics of this? And I'll give a couple of examples of what I'm curious about. You mentioned pen testing. Pen testing teams are usually very expensive, and to keep them in constant use here, which is really what's focused on, has to be balanced against other expenses, or even something as simple as the static analysis tools. Some of the tools actually charge by the line. And so if you're constantly running them overnight, the meter keeps clicking.
It's a great point. Instead of running everything over a project, we have to run for incremental things. So a couple ideas is using pen testing. It is not only for networking perspective pen test, it's about the application pen testing. So when we look at application, that has to tie back into my requirements getting. What is my risks? What is the risk that I'm trying to deal about in that application? If you know the risks, we can design the pen testing running that features only that I'm releasing instead of running everything else, or running the static code analysis only for that portion of the code that I'm committing to my repositories, which is saving the money instead of running every line of code. I'm going to run only the incremental portion of that code I uploaded or put into my repositories. Same thing, the feature release. If I release any features, then I have to do pen testing for that features only instead of doing overall application pen testing. So it's kind of like a life of the process. Like throughout the development process, we can really lay out the process.
So we have about a minute left to do, a little bit less than a minute. Can I ask one audience question to wrap up this on? And we got a question from Mark asking, we have been able to integrate both static and dynamic analysis into the continuous delivery pipeline. However, much success. However, how much success have you seen in the industry with the results of the scans? Automatically filtering false positives, duplication of findings, correlation of static and dynamic results.
So the answer to that question, I think once we have integrated into the tools into my development life cycle, so we can see a lot of maybe the false positive, but at the end, once we see all these things, we can go back in our development cycle and try to correct it. So eventually our testing will get much better and better, and we'll get more positive results than more false results. So it's kind of like a learning thing. That's the reason I'm saying that has to be overall integrated process, has to be part of the overall development cycle, not at the one point only. And then we have to go back and do that again. We have to go back for any incremental things we release it.
Got it. Son, thank you very much for your presentation.
You're welcome.